Well, good afternoon, everyone, and welcome to today's webinar brought to you by Mitsubishi Electric Heating and Cooling. My name is Ken Lancastle. I'm the COO with MCA Canada, and we're pleased to have a long-running partnership with Mitsubishi Electric Heating and Cooling, including their continued support as a presenting sponsor for our annual national conference. For several years, we've partnered with Mitsubishi Electric on a variety of webinar topics, including the A2L transition, the role of mechanical contractors in the shift to net zero. All of these webinars have been recorded, and all of these recordings are available on our MCA Canada YouTube channel, should you wish to visit there and see them again. So today we're going to hear a little bit more about a project that I think is near and dear to our presenting sponsor, is also very relevant for them as well. That's the retrofit of the Mitsubishi Electric head office and the efficiencies achieved from moving from a rooftop unit to a VRF heat recovery system and an energy recovery ventilator. I'm pleased to be joined today by Gary Chang, lead engineer, HVAC division with Mitsubishi. Gary has a passion for efficient and environmentally responsible HVAC solutions, and he's an experienced application engineer specializing in HVAC product application, development, and training. Now, before I turn things over to Gary to get started, I just remind everyone we do have a Q&A function built into Microsoft Teams, and we will have time for Q&A afterwards. So please feel free to put the questions in there, and we can relay those to Gary throughout the presentation and afterward as well. In the meantime, Gary, I'll turn things over to you, and the floor is yours.
All right, thanks, Ken. Hi, everybody. My name is Gary. I'm the lead engineer over there. Over here at Mitsubishi Electric, we are located in Markham, Ontario. So, which is just about 30-40 minutes north of Toronto. So today we'll be talking majority on our rooftop unit replacement with our VRF system alongside with ERV. And the weather will be majorly be referencing to Toronto weather. And then we'll share some weather data that we found, as well as utility usage data and some of the experience, and hopefully we'll be able to share our knowledge and then problem we face, or issue or challenge that we face, and then helping you to make decision or promoting different kind of technology. And again, feel free to use the Q&A section or Q&A button to ask any question and concern that you may have, and then we'll try to answer it as detailed as we can. Or we can take it offline, and then feel free to reach out to us. So without further ado, let's get started. So Mitsubishi Corporation as a company, we refer to as Melco. And then for Mitsubishi Canada, we are calling ourselves MESCA. So Mitsubishi Electric Corporation, and which we have to be in line with how our corporation target and goals. So Melco has been in the business for more than 100 years with about 150,000 employees globally with 213 subsidiaries. So we're definitely here for the long run. Therefore, our purpose at Mitsubishi Electric Group is to meet our requirement and mandate to create a vibrant and sustainable society through continuous improvement, through our innovation and creativity. So change for the better, and in order to meet our value, especially for humanity, environment, and society. And just on top of that is, as a corporation, we do have a sustainability vision of 2050. So our goal as a global company and as a Canadian subsidiaries, we are looking into to be net zero by FY 2031, which is try to use our in-house technology. And as people know, is we are very big on the HVAC sector. And so we are looking into using our in-house technology in order to provide energy conservation for our facilities. And then by 2051, again, our entire value chain through Scope 1, Scope 2, and Scope 3 will be net zero. So at the moment, Japan has 9 sites already 100% green energy by 2023, and over 10 sites on 2023 with net zero. So our goal as the facility or as the subsidiary is also to help achieve this goal. And for those who knows about or who don't know about scope 1 and scope 2 over there, just feel to Google and do a little bit research. It's called greenhouse gas GHG audit. So scope 1, scope 2 is related to internal usage. So scope 1 is typically referred to natural gas usage, fuel, fossil fuel may be related inquiries. Scope 2 is tied into electricity usage. And then scope 3 is entire value chain. So for example, procurement, manufacture of the equipment, etc., etc. So in here, so as a subsidiary, we're looking into mainly reduce our goal in scope 1 and scope 2. So Mitsubishi Electric has been in Canada since 1991, and we have been occupying a space for more than 20,000 square feet per floor. So it's a two-story building. Currently, we are occupying the first floor, and this building was built for Mitsubishi Electric Canada back in 1991 in Markham, Ontario. So the equipment has been there since for more than 30 years. So right now, well, not right now, but back in before the old equipment has been there for 35 years, is electric heating coil and the DX cooling coil inside a rooftop unit. And it comes with 10% opening for a fresh air. So we're mixing with retained air from the office and 10% from outside air, which is very typical for rooftop unit. And then inside the building through ductwork, they have VAV box, so fan power box with variable air volume and with electric preheat, as well as parameter heaters are typically found in like standard office. And the ventilation system, as well as heating and cooling, does have nights and weekend nights, and then seasonal switchover. And there is a computer server room that's supplied by dedicated cooling system. So with all all the description, that's looking into different just visuals. So you can see at the moment before 2022, we're using rooftop units, which is a 90-ton R22 rooftop unit that's serving the first floor. It is a trend rooftop unit within 2 compressor. Each one has 2 stages. And the heating coil inside the unit was never used. So we are relying on electric duct heater and electric baseboard heater for office. And in the office area, there's actually no natural gas. So about 30 plus years ago, we are already utilizing electric for heating and cooling. So it was a 90-ton rooftop unit serving first floor with fixed speed compressors, and then 10% of opening on the damper to have fresh air combined with recirculation air, with time-based setback as well as seasonal switchover between heating and cooling. And you can see they are pretty old, pretty beat up from the outside, right? From the photos. 4 condenser fans and all the equipment with 2 compressors, and actually 9 condenser fans, right? 575 volt, and be able to do effective heating and cooling. And on top of that, this is our cooling for our server room. So only 1 server room with 3 units. So the style is pretty old, you can see, and they have been using R22. But it is more of both units are still running. I mean, so for the so all 3 cooling only unit as well as the rooftop unit was functional at the time, but the rooftop unit throughout the year have many different issues, right? Like replace the compressor, leak, etc., etc. And it is R22, so we really want to switch over to R410A. and at the time when we do the installation, as well as the P series, even though they still work, so we still looking into replace them with, most up-to-date equipment. And the existing heating system with VAV and baseboard heater, you can see they are more than, I would say, more than 30 VAV box handling different CFN as well as heating for usually the core of the office. And then for the shell of the office, we're using electric baseboard heater. Some are connected to VAV boxes. Some units are provided with onboard controller. And we typically assume for electric heater, the COP is 1. The coefficient of performance is 1, which means the heat, how much, whatever power input you have on kilowatts is how much heating you can get from the heating side. So in many cases, they're considered a pretty big energy drain compared to some of the most recent technology, such as inverter-driven compressor or heat pump technology. So that's really where you can see. So, but in the last 30 years, we have been using electric heat, providing heating and for light heating, as well as using R22 compressor and to provide cooling. And however, throughout some during maybe I can't really recall, that was before my time. So more than 10 years ago, we also have a section of the office that was actually converted with geothermal. So this part of our office is actually using two 8-ton condenser that's connected to geothermal. And it's a lot more comfortable compared to the rest of the office, and then a lot better precision control and be able to handle the mold. So that's why we're really looking into, let's just change it over to a new system and then having our office run with it. However, for any retrofit project, there are challenges. And even though Mitsubishi has been occupying the office for many, many, many years, we lease the building. So the building is actually we lease it from the landlord. So one of the requirements from the landlord is existing ductwork, VAV box, heater, etc., etc. All the equipment must stay. Just in case we move, then and then we remove all the equipment, then they have to be turned back to its original states and original. So that's why the VAV box, the ductwork, the heater must stay. On top of that, usually with VRF system, one of the challenge was the small offices, right? So you can see some of the offices are a little bit too small for VRF system. And we want to incorporate that. We want to make sure our design can accommodate for those kind of small offices and still provide comfort like we will do for, you can see the large open office area you can see over here with VRF system. So and on top of that is really the major challenge, while not a lot of people talking about it, it is occupancy comfort, and as well as setting up the system to be proper. So over here, you can see this is the rooftop unit that's currently serving, that was serving the office. So I sit here, which is pretty close to the rooftop unit. The general manager for the president of Mitsubishi Electric sitting here at the corner office. And by any time, he needs to be the most comfortable person, right? In my idea is he has to be comfortable, but you can see the ductwork has to travel all the way to this side. So that means when he is nice and comfortable, this person, like myself, and others may not be as comfortable, right? And vice versa. If I'm comfortable, there may be some loss. especially he's on the corner office with windows. And then on top of that, over here, we have our Mitsubishi automation. I believe he's the president or vice president for Mitsubishi automation. So he's sitting here as fairly close to the rooftop unit. So sometimes through ductwork, through that, it's hard to make sure everybody's comfortable. And then on top of that, it's all the people on the corner as well. So really, we want to improve comfort while maintaining the energy efficient. So, and then we already have the mind of, Mitsubishi Electric, we offer many different kind of solution. So, but one thing is we really want to utilize heat pump with inverter driven technology, because you can see this is taken from Environment Canada historical value. So you can go to the website and then download the unit, download the temperature and then profile and then plot it out yourself. But you can see from July 6, 2021, even throughout the day, they go from 23.5 all the way to 32 degrees C, right? So throughout the day, the weather change. Same thing for both heating and cooling. So therefore, we're looking for inverter-driven technology that can ramp up and down to accommodate for the change of temperature as well as occupancy, right? So for example, like I'm currently sitting at my home, so therefore I'm not in the office. So therefore the heat loss, what heat gain from the office may be one last person, right? Because I generate heat as well. So the occupancy change pretty constantly, right? Like it's always changing. The weather is always changing. Therefore, we are looking for inverter-driven technology to really help with the heating and the cooling side of things to make sure it's comfortable while maintaining the set point. So there are actually three options. First one is the easiest one is, you know what? Let's maintain, let's keep the existing rooftop unit. And let's retrofit it with what we call an LEV kit. That means we are just taking out the DX coil inside. We remove all the condenser fan from the existing units, but we retain the belts, the fans, the control, the thermostat, everything. And we are simply just replacing the internal cooling coil with a VRF coil to still meet that ever change of temperature. This is a popular design. However, again, the president is sitting here, I sit here. So that still have a lot of lost for a large office like us, right? But so maybe if we have a small office or smaller scale, this may be the most intuitive option. And secondly is, you know what? Second option is, well, direct replacement. Let's remove and replace this entire rooftop unit. Just replace it and then replace that with our own package heat pump system. So we still have, as you can see, this is a heat pump system with condenser fan. We have heating and cooling coil, and we are implementing an ERV inside. So that's another option, but we're kind of facing the same thing. As option number one is to retrofit it with VRF system. As you can see over here, even though we have all the cooling coil and the compressor all built in, just drag and drop into the building. However, it still doesn't really address a lot of issue that you may see. And on top of that is there are a lot of control that you need to implement it, right? So we're dropping a very state-of-the-art system into an existing building and then needs to make sure the control works. And that still doesn't address the whole, moving air through a large distance. So over here, you can see that's another issue. Even though it addressed the challenge that, the landlord wants us to leave all the ductwork, the VAV box, everything is there that we can utilize. But again, that may not be the most efficient solution that we can see, that we can use. for this. Then obviously we are choosing what we call VRF system with zone-to-zone ERV. So basically you can see we have to retain the existing ductwork VAV box, but we don't need to utilize it. We can perhaps cap it, just not utilizing it, because we have refrigerant piping from condenser all the way to different fan coil unit that you can see over here. Excuse me. Yeah, you can see from the condenser to different fan coil unit with smaller refrigerant piping. So refrigerant pipe compared to ductwork on the air side, it can be smaller. And on top of that, we are also utilizing zone-to-zone ERV because people are in and out of the office a lot. So therefore, if nobody's there, just turn off the ERV or turn the ERV to low speed. So instead of providing full building ventilation. So you can see here, our final decision was ERV, a VRF with ERV, because refrigerant piping also needs to be insulated. And you can see we are placing the VRF system closer to the zone that is serving. So that will reduce the amount of piping as well as the amount of ductwork that needs to be that's associated with running along ductwork as well as refrigerant piping. And we're just having different ERV taking outside air and providing indoor. So we're gonna go into a little bit more detail on that, on the solution. And on top of that is we're using VRF system. You can see just small refrigerant piping into what we call a branch box. And then branch box will be able to provide heating and cooling at the same time. So for example, if I'm in the office, so instead of June 26th, let's imagine this is October 15th. I need cooling and some of you want heating. Therefore, the unit itself can have heating and cooling at the same time to meet your demand. So that's also increasing comfort for many cases. And the more you use it, actually, the more efficient the system is. And some of the challenge that coming in is that we're facing during the design when back in 2018, installation in 2022, was CSAP 52. So for example, some of the offices are very small. So we are forced to have perhaps a smaller unit, so one fan coil unit that you can see serving different zones. So actually, this two is showing one thermostat. This two is showing one thermostat. This three is showing one thermostat, and this two is showing one thermostat. However, we're increasing the amount of the quantity of control, so people can have a better compromise, if you may. But that was the challenge back in 2022, 2018. However, now there's a new solution or improved solution available in the market, what we call HVRF, where we combine both equipment. That we can address it, and that's our goal to do future improvement as well. So we address that. So coming back is on top of the heating and cooling side of things, on the heating and cooling and then provide comfort, we also provide zone-to-zone ventilation with ERV. So for those who don't know what ERV is, so it's what we call energy recovery ventilator. So imagine right now is if you don't have an ERV, you are dumping the nice cold air, right, from outside, from that you're utilizing your air conditioner, and then provide cold air into a room, and then you're dumping it directly outside, and you are taking 33 degrees C outside air and then put it into the room, which you are heating up the house. So in that case is we're utilizing zone-to-zone ERV, where you can see 33 degrees C of outside air comes into the building, is actually being cooled by the inlet, I mean your room exhaust air. So we're turning it from 33 all the way to 24. Therefore, your air conditioner can work a little bit less. And on top of that, you can see this is a pretty good chart is, let's say a building in the morning or during the daytime, everybody's in the office, but sometimes we have guests from overseas, we have auditors and all that, accountants, etc. They may be working a little bit late. So they have to, so in those cases, we don't have to provide fresh air to the entire building. We just have zone to zone ventilation for each zone that require the minimum fresh air or the recommended fresh air value for each zone. And on top of that, we're able to have different fan speed. Perhaps it can be on time, it can be on occupancy, and on CO2. So we put our mind into it. So what do we do? First thing is we need to have engineer analysis on energy, heat loss, heat gain calculation, as well as structural changes. So pretty simple, pretty basic, pretty intuitive is the engineers that we hire, the consultants, they provide energy analysis, and then do heat loss heat gain calculation for us to select equipment. And because we are placing the condenser on top of the new on top of the roof that has not been previously maybe enforced or having mechanical equipment, then we are having structural engineers to also look into it. So the idea is we are finally finishing it. We actually go with from a 90-ton R22 rooftop unit into a 60-ton air source VRF system with heat recovery. So some of the idea, and when I'll be honest, when I first when me and my team we first look at into the design, like from 90-ton to 60-ton, that is quite a change, right? But it turns out is, first of all, we're utilizing ERV to significantly bring down the load requirement on the ventilation side of things. And on top of that is the equipment back in 30 years ago, right? The monitor you are using is humongous, right? And compared to the ones that we're using right now, the laptop, the computer, and even for our Mitsubishi office, the data center used to be the data center for our operation used to be the entire server room, but now they are just 2 racks. And then instead of cool the entire room, we can do precision cooling for the racks, on the inside the room, right? So we are able to provide still cooler room, but the heat loss, heat gain has significantly reduced because the equipment has been much more efficient. And on top of that is, like there used to be a QA, some sort of manufacturing back to the old days before my time. So we are really able to switch it from a 90-ton to 60-ton. And on top of that, a trend unit for any rooftop unit that was built 30 plus years ago, 30 years later, it is not performing at its peak performance. So we have a couple of different opinions. Then we are okay with 60-ton. And then even last week throughout the heat wave, or last year throughout the heat wave, people are fairly comfortable with the 60-ton air source unit. And we are dividing into different zones that you can see. So we're actually having smaller zones that you can see over here to have that precision control, and then to have that comfort level on the zone level with the thermostat. And fresh air via ERV has helped quite significantly, even though we're using 30% extra fresh air on top of 90.1. So, right, to have as much fresh air as we can for the building, and then to improve productivities and comfort. And lastly, we have central controller with remote control capability. So we have a central controller on the site, and we have a remote control that people can access, the facility manager can access. And on top of that is their projected saving that we'll do a comparison shortly. So you can see we save quite a lot of electricity based on the energy modeling, as well as operating costs just per year. And we'll share some of the information, some of the study we see. But on top of that is we're also thinking about future expansion as well to have combined VRF with hydronic system just to improve comfort as well as efficiency. So if we are doing a retrofit project, maybe not just thinking about right now, but also think, right, like as if you are a business owner, if you are a management team, or even just engineer like myself, there is a certain place you want to be, right? There's a certain place that your company needs to go. So maybe you will have more people and then you need to divide more petition. So, thinking ahead the future and having some sort of plan as well. And then where VRF will be able to address those concerns because we are using a fairly significantly smaller pipe. And then they come with many, many different styles to be able to accommodate for all the existing unit, the space that the existing unit or the existing pipe run, duct run has been occupied the space. So we have different style that's being utilized, and then they can be pretty compact for different places. And we are utilizing centralized controller and remote access to be able to see what's the operation index, what's the comfort index, and what's the status through remote monitoring interface as well as centralized controller. And you can see we change it from this unit and we'll be able to spread out into this smaller block, monoblock installation throughout different buildings, throughout different zones. And compare that with a rooftop unit. We're actually, so this is the energy model between constant air volume, that's from the rooftop unit, versus VRF system. And you can see we drop the usage quite significantly on the energy model. So we're pretty excited about it. So then we start to track our own usage. And you can see, and then we start the construction. So we are a corporation. We typically go with financial year. So we start the construction sometime between financial year 2022, so starting about July 2022, and finish it in operation in about throughout the year of 2022. But during the time, there's a lot the tweaking, a lot of control. At some point, I know the rooftop unit and our indoor VRF is operating together. At some point, I know the baseboard heater and the VRF heating system is operating together. So we're able to get rid of all that control and then find out, because a lot of time, oh, what is this breaker that's on the corner that you don't know, right? Because it was built 35 years ago or 30 years ago. Then do that. So we finally be able to get rid of all the kinks or optimize the system. So I'm strictly looking into FY 2023 and FY 2021, where we're running full 12 months with rooftop unit and full 12 months with a VRF system. But if you're curious about FY 2022, we can also take a look offline as well. But over here, you can see we save quite a lot of electricity usage, moving away from the rooftop unit with 100% electric baseboard heater or the electric heater. So we save quite a lot of greenhouse gas equivalency. You can see we're saving literally between about 20 homes of energy usage in a year. And that's based on NRCan, Natural Resource Canada calculator. So feel free to utilize that as well. And on top of that, you can see we are also reducing the greenhouse emission. And this is based on, that's where we talk about scope 1 and scope 2. So greenhouse emission scope 2, and this is based on because the NERC, North America Electrical Reliability Corporation, divide North America into different grids. So sometimes, like you will see they're divided into different zones, different areas for the entire North America, right? So that's why you will often see they will maybe location based, right? So you are based on different location in North America. So you can see the significantly decrease in electricity from rooftop to VRF system. And on top of that is, in some jurisdictions, some location, even though you guys are using natural gas as the primary source of heat or coal, but again, if we can reduce the power consumption on a local level for every single building, then your power consumption or power generation from the source level can also reduce. Then you are able to reduce your greenhouse gas emission. And over here, another thing is we're also looking into, let's look at just Ontario, because we are located in Ontario. And in Ontario, we use a lot of hydro, right, from maybe Niagara Falls, and then as well as nuclear. Therefore, you can see if we're using the Canadian emission factor, again, even though the scale is pretty much the same, we reduce by 47.5 or 47.6%. The overall emission is lower. So again, that's something you can look into, but both is we're achieving our target of significantly reduce our greenhouse gas. And next interesting thing is you can see we are reducing our electricity usage a lot by about 47.58%. And our electricity bill also reduced about from quite significantly. So from 54 and then to 543 megawatt hour, and then we're able to save about 53 grand a year. And that's just on electricity usage, and not on top of the, the leaky rooftop unit, that may have refrigerant that's been leaked, the compressor, etc. Right? And we don't have this value, so actually we may be saving a little bit more. So next, on top of that, we start to implement schedule and setback starting in May 2023. So you can see over here, in May 2023, you can kind of see the weekends and nights, how people are using the VRF system, right? And then how it's behaved based on outside temperature. So again, this is not HVAC usage. This is the entire building usage. So before the setback or before the weekend and nights and setback, you can see the building electricity is all over the place. But once we do the setback in July, you can see clearly nights and weekends. Right? So weekends usage is obviously pretty low. And then during weekday, they are actually increased throughout the day and then gradually go down during the day. So in the summertime, we're actually saving quite a lot of electricity over here compared to here, or even compared to when we're using rooftop unit and VRF together combined in many, many cases over here in FY 2022. So we actually save quite significant amount of usage in winter. So in here, again, just before and after scheduling. So on top of that is we are able to perhaps utilizing purchasing electricity from someone else, or actually implement solar PV to help reduce the electricity consumption even more due to scheduling and setback, right? So you can see our baseline used to be about 40 megawatt hour, but now we are looking at about 20 megawatt hour. And same thing for winter. You can see December 2021, this is using for electric heating. And we're going into 2022. Some are using electric heating, some are using VRF for heating. And then to December 2023, we're able to really do a setback. And then weekends, you can see we are also reducing the baseline heating quite significantly, between 140 for many cases. And so I think cooling is pretty obvious for many things. Is first of all is the weather is constantly changing, right? And a 30 years plus old fixed speed compressor versus inverter driven compressor, then obviously the VRF things will help with the changing in to accommodate for the loads, as well as accommodating for outside air temperature while providing comfort. However, in winter, but keep in mind, we have electric heater versus VRF heat pump. So that's where we refer to coefficient of performance. So electric heater is usually we're referring to coefficient of performance of 1, whereas VRF can have COP of 2, 3, up to 4 in certain cases, and depending on load. So that's where the COP comes in and out. And sometimes when I do the presentation, one of the things that people will say is, we all know in the last winter, in February 2024, we're pretty warm. The coldest temperature is maybe -15. And then we compare that to, let's say, 2022. And this is the February hourly data from February 1 a.m. all the way to 28th, 29th, and then in certain years. So you can see the temperature fluctuate quite a lot. So how do we say? So a lot of people will say, well, we are having a pretty warm winter, and then, et cetera, et cetera. So in order to see, and that's also for our own curiosity, is you can see even though average temperature is minus 0.35 in 2024, but sometimes we all know in 2024, they go as high as 15 C, right? And as low as -15. Whereas 2022, even though they're -4, as an average temperature, we know they go as cold as -23, 24, 22, 23, and then as warm as, oh, sorry, that's 2023. So as warm as 15, and then 2022, 2022 wasn't that cold actually. So as cold as here versus the high over here for some time. So I was like, well, average temperature, etc., may not be a best picture or screenshot or what's happening. So I pick a date, February 1st. I just pick a random date. So February 1st, and I say, during the daytime from 9 till 5, our office hour, people are in and out a lot. Maybe the equipment that's using, somebody forget about fridge, right? Or leave the window open or the door open. Okay, let's look at nighttime. So February 1st, I know nobody's here after 7 o'clock. And so let's just pick some day that's close to the weather, right? Temperature. So let's say 3.3 on FY 2022. So February, sorry, not 20, FY. So February 2022, February 1st, 2022, 3.3 degrees C outside. I'm using 142 kilowatt hour of electricity for the building. Because I know during nighttime, lights are off, only heater is probably on, and maybe some of the equipment is on, but majority of people are gone. And then I look at 3.2 degrees C or 3.3 degrees C at 9 p.m. So I'm using about half of electricity or slightly more than half. So I know, well, it kind of makes sense, the COP between electric heater and heat pump, just kind of doing a sanity check, if you may, then I know the COP is performing pretty well. And then look at over here, -3.2 versus using perhaps VRF as heater. I don't really know, but heater is perhaps using the temperatures quite significantly. But again, that's during daytime. So don't know. During daytime, it's kind of hard to say because I know people may be in and out, especially 9 a.m. in the morning. And then same thing over here, I have 1.3 degrees C at 11 a.m., 1.2, and then 1.3. But again, they are different place, different occupancy, so it's kind of hard to make that judgment. However, I know that, between heat pump system and COP can be, between a heat pump system and electric baseboard heater, and that will perhaps be a very good comparison. And let's pick another day, February 14th, minus 4.4 degrees C outside, and I'm using about 71 kilowatts. So that's about, so you can see between 6 and 7, there's a sudden drop. So I know perhaps that's people are actually leaving and then turn off the lights, and then we do have people that start to coming in. But you can see at 9 p.m. minus 4.4 is about 71 kilowatts, and then minus 4.2, minus 0.6 at 9 a.m., 10 a.m., and 155. So kind of in line with what we've been thinking and promoting, right, during the nighttime. And then again, 3.8, then 100 kilowatts. Then there are further study need to be considered. And then perhaps both heat pump and electric baseboard heater was operating at the same time. So many things in 2023. But in here, we just randomly pick up some dates and then looking at electricity usage, and then need to do a little bit further comparison. But overall, in general, we do see a significant reduce in the electricity usage after we implement heat pump system as well as VRF system. And then on top of that, we're switching from before scheduling to actual scheduling. We also realize quite a significant saving, especially we are able to utilize ERV to provide cold air. Maybe first thing in the morning to bring outside cold air into the space to purge the building, provide cold air. So we are able to save pretty high realization on the electricity usage as well as on the volume. And also thinking about ahead in the future, because the team is also growing. So we are able to have future modification and expansion to combine VRF and hydronic for some of the zones to further improve comfort as well for our just usage for our equipment. But before you do a lot of heat pump or incentive or doing some energy saving, don't forget there are other opportunities as well. So throughout the year, Mitsubishi, we have changed the lighting. We have sealed the door, sealed the window to make the envelope a little bit tighter, right? And then having a better building operation. So before it was just turn it on, turn it off, but now we are actually saying different time, different equipment goes in and start up. So be able to have better building operation and perhaps having lower electricity bill based on your operation. And furthermore, we are looking into the future as we do also reduce our water usage, which is also tied into our sustainability goal, as well as implementing renewable energy to offset some of the electricity that will be used. Especially now, we know what our baseline in the summer months will be, and our baseline for the winter months can be. Then we know at least that will be how much electricity we can purchase at those states. During those renewable energy or carbon offset for those pricing. So thank you very much. That concludes my presentation.
Thanks, Gary. Great presentation. We did have a couple questions that had popped up through there, so I wasn't sure if you saw them, but I'll go in order of the questions that came in.
Yep.
Perhaps not related to this particular project, but the question is, yesterday I read in the news, Mitsubishi Electric is announcing the release of new equipment on the refrigerant R454B. Is it possible to tell us any more about this?
It's a new refrigerant. It has a lower global warming potential, and then which is in accordance with what the US and US law and their target is. So 454B has lower global warming potential, and then it's a new refrigerant that's coming. So
Stay tuned.
yeah. Um,
There was another question. How did you overcome the landlord-tenant issue on this project?
um, we are not really so obviously it is a long discussion to switch, especially from a rooftop unit that many people use for many years. But again, we are Mitsubishi Electric. We sell and provide HVAC equipment. So really, that's not really a question of no, we must use our own equipment, right? Because we talk the talk, we must walk the walk as well. And then that's why one of the requirement was if we moved, then everything will be put everything interior will be back to its original states. And then so that's why we can't really just install a parallel rooftop unit. We cannot really parallel do a lot of different things. So we found VRF because the the refrigerant piping is significantly smaller compared to a ductwork, and then minimum disturbance for the indoor interior side of things. Then eventually they go around and I hope our facility manager is also sharing this data with them and say there is a significant saving with newer technology, right? And then R22 is really we shouldn't be using R22, right? For a lot.
I know you got into some of the numbers. You showed some of the numbers on the screen. There was a
Yeah.
question. What was the payback on this project? I think you went over it, but is there anything you want to really reiterate?
Yeah, we don't have we actually didn't go into a lot of detail on the payback analysis our internally. It's because we know our equipment is more efficient.
Mhm.
And then as a Mitsubishi, we are able to get our factory discount, right? So, and then a lot of times it's also partnership to do it. So it's really hard to calculate payback for many people, right?
Right.
Like for especially when like I'll be honest, the price we are getting is probably different than even if I go to a dealer, if I want a Mitsubishi unit, I am getting a different price than Ken, hopefully,
Yeah.
right? Hopefully.
Yeah.
So payback wasn't really that big of a deal for us to analyzing. It's more of we have to switch, right, to save more on the electricity as well as usage. And then we have a lot of buy-in from our team as well. So I will encourage if it's something that you are interested in doing, our team, our distributor will be able to help you. But I will also say this is don't look at on the equipment side of things.
Right.
Look at the entire project, right? Refrigerant piping versus aluminum on the ductwork and the insulation, right? So all that jazz, someone need to crank it up and then drop it, right? Connection, uh, bring natural gas if we have to use natural gas or we're switching over to heat. So yeah, we didn't actually do a detailed payback period or payback analysis. It's more of we have to do it.
Well, certainly you have the numbers on the energy
Yeah.
usage side and things of that nature
Yes.
as well. So,
Yeah.
there was another question again, not related, I think, necessarily to this project. When is Mitsubishi planning to adapt or bring in new equipment with new refrigerants?
So the first refrigerant. So actually, so our first R454B equipment will be for our like rooftop or makeup air unit, air handling unit, um, system. So R454B, that will be available, actually being specified in August. That'll be the first one to go. And then we are slowly, gradually transition for our residential, I will believe, our residential system or the mini split into the new refrigerant, and then gradually go into a larger system. So, which is pretty much in line with what the U.S. government, the U.S. EPA is planning on doing in terms of on a larger scale. But for Canada, I'll be honest, I don't really have a concrete schedule for that, for announcement, as well as there are local codes and standards to say what you can do. So for example, CSAP 52, one of the question I was asked is R32. It's like, well, if you're using B52 2013 or 2018, I think it's very challenging for you to use those A2L refrigerant at the moment for your project. But if your local jurisdiction is adapting to the 2023, 2024 version, then that's a slightly different story. So we're just kind of keeping close eye on what the announcement is and what it look like. And we do have an election coming up for US and then for Canada as well. So yeah, so things may change. But again, as soon as we know the dates, then we'll announce it to everybody. And on top of that is, Mitsubishi, UK, Europe, they are already using R32. So
Well, there's no other questions have popped up. Gary, I'll slowly give a chance for any final questions. But in the meantime, on behalf of MCA Canada, I just want to thank Mitsubishi Electric Heating and Cooling once again for taking the time, sharing your expertise and experience on this and on this particular project. Obviously, congratulations as well for what you've seen and the results of this project as well. And again, we appreciate the ongoing partnership with Mitsubishi Electric Heating and Cooling. There's a final question did pop up. Presentation very well delineated the energy saving in comparison between VRF and RTU. The main concern when it comes to Mitsubishi is initial cost, which is something we couldn't see in the presentation.
yes.
I'm not sure if you want to speak to that, Gary, or
Yeah, so I'm an engineer over here, so I don't really see your just general contractors costing as well. But again, I would encourage you to come and talk to our team or our distributor, and then yeah, there will be a way to resolve it. And then same thing is, sometimes. So, and that's why we are also looking into three different options, right? So first one is what would be the cheapest solution? Well, let's just get rid of DX coil, putting a new condenser like a Mitsubishi condenser, and handle perhaps the smaller zones, right? So that will be the most economic kind of solution. And then, or you can just replace that with a packaged heat pump system, right? So that's another option. Or you can go full blown on VRF. That's really depending on the project size. But unfortunately, like what I say, is we actually didn't put in a lot of emphasis on studying the old products or the existing equipment as well as cost. It's more of let's looking into what will be the best solution. And advantage for me is also you can see over here, we're using heat recovery system with what we call high efficiency equipment. So it is the most efficient equipment that we have in our product group. And then also hyperheating system, because certain people needs to be extremely comfortable. So there are ways we can maybe do value engineering on many cases, right? And or in some cases, maybe always another thing is I do know heat recovery system is slightly more cost than heat pump system just on equipment side. But if we know the cafeteria, why do you need heat recovery for cafeteria, right? Then in that case, perhaps using heat pump instead of heat recovery, then that's something that we are able to do value engineering on. So hopefully I answer some questions, some concern. But yeah.
Well, again, Gary, I appreciate you taking the time today and your expertise here. I think that's it for questions. There will be a recording of this, as I mentioned earlier, posted onto our MCA Canada YouTube channel. And again, thank you to Mitsubishi Electric Heating and Cooling for the ongoing partnership with MCA Canada and all that you do for the industry. So thank you.
Thank you.
Have a great day.
Bye bye.